Hi guys, welcome to Simple Programming. It has been quite some time since I made a video, but by the look of this video title, you might have guessed why there has been a delay. If you have guessed that I was preparing for interviews, yes, that's correct. I wanted to share my experience for a backend Java developer interview. I believe these questions will give you an idea about the expectation in the market now. So let's go in and look at the questions that were asked to me in these interviews. I was interviewed for a senior microservice developer role, and the interview spanned for like 2 rounds. Let's look at some of the questions. So the first question was like, what are the disadvantages of microservice? And the interviewer asked the answers from my personal experience. So from my personal experience, right? So I gave at least like 5 or 6 disadvantages, which I thought might be the disadvantages of microservices. So the thing is like I told like your entire ecosystem becomes distributed network, right? When you go for a microservice architecture, so you'll have to deal with distributed system development, deployment, and have to look at new expensive components and softwares to achieve this. The thing is like let's take a simple example of cache, right? You'll have to you have to do a distributed caching environment for your microservice architecture. Your database has to be distributed database, and there are a lot of things, there are a lot of elements that come into place when you go for a microservice kind of architecture. And then I talked about the integration testing, which is definitely a harder and painful task when you work in microservice environment, especially the automation testing, the complete end-to-end integration testing of the components. These are like pretty hard and pain in the neck tasks when you work in microservice architecture. Then since you're going to break down your components into multiple individual and smaller components, your ecosystem is going to become a very huge system. So obviously network traffic increases because let's say for example your microservice, each microservice talks to other microservices in your architecture. Then obviously the network traffic is going to increase, right? So these are things that you have to take care. And the next point is like you can talk about the DevOps setup becomes complex. Your deployment becomes complex. There are a lot of things that you have to take care for deploying your artifacts into the server. Your DevOps setup becomes complex. Let us say if your service spans across multiple systems, then operational cost of deploying and managing those services and systems will be more from your traditional setup. Think of hybrid cloud systems. Like if you have multiple microservices, few in AWS, few in your in-house cloud environment or a private cloud environment. So this becomes a hybrid. So you'll have to take care of different deployment strategies and other different strategies to have the systems seamlessly work in CI/CD processes. So this is one disadvantages. Then let's say if you have a hybrid architecture between, let's say you have an SOA architecture and you're going to implement microservices for new services. So these go hand in hand, and definitely that the integration between these is not going to be easy, and that has to be put in a lot of extra work to have a seamless integration between these kind of architectures. And let's say if your system is not in cloud, then microservice might not give a meaningful benefit to you. So one of the advantages of going to cloud is like you can scale and your system will be highly available. So if you're not going to do a cloud-based environment for your Microservice for your architecture, then microservice might not be your ideal choice. And definitely there's one more example, which is like from my personal experience, like the entire team culture becomes different when you work in a microservice architecture. Mostly it would be a T-shaped model. The things that I have seen in microservice architecture teams is like mostly the teams will be a T-shaped model, and there's a lot of things that you have to take care of. The entire team culture changes, too much of documentation due to multiple system frameworks and all those stuffs. So these are some of the disadvantages that I can think about personally from my personal experience. Let's go on to the next question. So consider there are like 10 microservices in architecture. How will you secure the communication between M1 and M2? So before we move on to this question, I just want to tell you, like, don't think microservice as like a completely new thing, new kind of some buzzword, and completely everything has to be done in a new way. You can actually use few of your old technologies and old stuff to implement microservice. So think microservice as like two different systems that you have worked in an existing project or existing work. So that will give you an idea like how two different systems work, and you can actually build your own knowledge on how to how different artifacts work between these two different systems. Think of, for example, let's say you have a project, you're interacting with a third party. Think these two as two different microservices. Think of the different ways these two communicate with each other. What are the different things that are established between these two to have a seamless communication? These will give you a lot of ideas about different things that can be established in a microservice architecture. These are things that you can bring forth in your interviews too. So for this question, right, you can just say, let's say if you have a so for service to service communication using HTTPS, you can do OAuth 2.0. You can use a HA proxy with Active Directory Federations services if you work in an enterprise, large enterprise employees and companies. Right? Obviously, they'll have Active Directory, so you can use this to communicate with two different microservices. Then you can use a API gateway to to federate the communication between these two systems. And there's a lot of things that you can do, like you can restrict network access between microservice A and B and C. Like there are a lot of things that you can do with respect to communication. So you can actually put in different points for this thing. Okay, so the next question was like they asked me to talk about the different microservice architecture patterns, designs that I worked on. So there are a lot of things that you can talk about, because if you Google about this, right, you'll have a lot of design patterns available in the market. Just make sure that you understand each and every design pattern, so that if they ask you a cross question on that, you should be able to answer. So um, you can talk about per service database microservices. You can talk about shared database microservices. There is CQRS available, event driven is available. Then there's a Saga pattern available, and you can have a log aggregated microservices. You can have a chained microservice design patterns, proxy microservices, API gateway microservices design patterns. So there are a lot of design patterns. So if you go and Google about the design patterns that I talked about, right, it will give you a lot of knowledge on about the different microservice design patterns, and you can really use this in your interviews. So let's move on to the fourth question. So consider each microservice as individual data source. I have a requirement to join data from two data sources. How can I implement this? So this question is like we have actually used this particular way in our project. So it was pretty easy for me to answer to this question. So I'll give you an example. Let's say you have microservice A, which has its own database. Microservice B has its own database. So you want to, let's say you want to do when a request comes in, right, you want to join these two databases to provide a result. You can do one thing I can think of is like you can do the CQRS here, like command query responsibility segregation. So let's say, so what exactly CQRS does is like CQRS suggests splitting your application in two parts, the command side and the query side. The command side handles the create, update, and delete request, whereas the query side handles the query part using the materialized views. So this is one actual way of joining two different services with individual databases to fetch data. Okay. So then the fifth question was, what is the difference between at the rate of component and at the rate of bin? I made a very detailed video in my Spring Boot lecture in one of the videos. Please take a look at that. I talked about different between the at the rate of component, at the rate of bin. What is the importance of having at the rate of response body? What is the importance of response entity? All these things. I have talked a lot about this, so that will give you an idea about this. Okay, so the next question was about Spring transaction management and how to implement that. So these are questions that really would show you how well you have worked on your project and how well you know the Spring concepts. So these are the questions that you can talk about for a very long time. So to start with, you can say that there are multiple ways to implement transaction management in your project. Like you can do it programmatically by using this legacy entity manager factory and creating a transaction object and doing a begin and commit and rollback manually, or else you can use Spring version of transaction manager, which again there are two versions in that Spring management. One is programmatic transaction management, other is declarative transaction manager, which uses that at the rate of transaction. You might have noticed it in your different projects. So you can talk about these things about in detail to the interview to show that you are very well versed with transaction management. Because if a developer knows what's exactly happening, behind the scenes when a request comes in and goes to a database and comes back, right, it really shows that okay, this guy is really techie and this guy knows a lot of stuff about what's happening in the background. So it's a plus point for you, especially in the interview. So you can talk about all these things like a transaction template. How can you programmatically, when you use a Spring transaction template, right, how you can implement this. And then you can talk about the declarative transaction, at the rate of transaction, and you can talk about different elements of the at the rate of transaction, like the isolation levels, the read commit, read uncommit, repeatable lead. And you can talk about the timeout factors. You can talk about the propagation is like if transaction is needed for this particular method or not, if transaction is mandatory, if it required, or if a new transaction has to be created, and all this stuff there. And you can also talk about a rollback feature. Like let's say if a particular exception happens, you can actually roll back only for this particular exception, and if you don't roll back for this kind of exception. So these are things that you can actually talk about. And when you're going to finish about this, right, you can talk about the importance of having transaction on the service layer instead of the DAO layer. So these are the things that differentiates a good developer from a developer from who was really hands-on on his application than a developer who has read different things in his in the Google and internet. Okay, so then let's move on. So the question was like, have you worked on futures and completable futures? And then they asked me about the difference between future and completable future. So these are questions that you can talk about for a very long time. So to start with feature, right, you can actually talk about the callable interface, like what happens, what is the importance of having a callable interface. So when you work on threads, right, runnable doesn't return anything on thread completion, whereas callable returns the result of the completion. So future when a callable method completes, right, the answer must be stored somewhere, right, and that object is a future object. So then you can talk about the completable future. The first talk about the disadvantage of future. So future is not exactly completely asynchronous. So there is a wait when you do a dot get in future, right. Obviously there's a wait. So completable future overrides this and becomes a complete asynchronous wait. So when you use a completable feature, it can explicitly complete by calling the complete method without any transactional wait, so any asynchronous wait. So these are things. Then if you work on reactive components like Flux and Mono of Spring, right, you can say how you can use Flux and Mono instead of completable feature. These are things that you can actually talk about in the interview. So then the 10th question was really something that I never expected someone to ask me that question. So this was like when I was in a Skype interview, the interviewer asked me to share my screen, and he asked me to open up Eclipse, and he gave me the scenario and asked me to code it right away. And whenever I was writing something, right, he asked me a lot of questions on that thing. So the thing was like, write an API to observe a list of students and do a post put and sort the list by name, and again sort it by age before sending it back. So you can see here there are two different sortings. Okay, so I opened up my Eclipse, and when I created my Spring project, the questions started from there itself. Like he was asking me like, what is the importance of a parent tag in the pom.xml, and how Spring Boot dependencies are managed, and these are things. So So one good answer for this, like you can say, like the Spring Boot dependencies are managed in a multi-module project. If you worked on multi-module project, right, you know how that dependencies are managed between two multiple different projects inside that same project. So you can actually say this is the same concept that is used in Spring Boot and all the things. So then he was asking me about what is serializable, what is the difference between one LN generated between serialized UID version. So he was asking me what is the difference between these things, and he was asking me if you face any issues if all the classes have one L. And these are like pretty much straightforward questions, right? So, and when I used response entity for my post and put, right, he was asking me why are you using response entity, why can't you send it as it is, and I was talking about all these things that comes within the response entity. That's a very detailed video about this in my in the Spring Boot lecture. You can take a look at that. So then the common question that every Java developer goes through, difference between comparator and comparable, and he was asking me collection about the collections.sort, and then comes the multiple comparator. So this is pretty new, okay? So there was like if you want to do multiple comparison, right, you can actually do there is a dot then comparing introduced recently, so you can use that to do multiple comparisons. You can do two different comparisons, okay? So I was using this and I was coding live by sharing my laptop with the interviewer, okay, my laptop screen with the interviewer. And then there were questions about method references, there are different types of method references, right? So he was asking about all these things, and then obvious question was like Java 8 Lambda expressions. Then what is the difference between a put and patch? So these are different things. Like patches, like if you want to update only a part of your object, right, part of your record, then you can use a patch for it. So then he was asking me like how would you ingest a patch request. So I said like you can do it through a map, okay? Obviously the request that comes into your application, when you're using a REST application, right, the request that comes in is going to be a map of elements. So you can use a map to ingest the unknown elements and then map it to the different elements in your database and update it. So that's few things that I explained. Then he was asking me about my containerization experience, and I told him like I was using Docker, all the stuffs, and then the next question was like about the Docker swamps. So this is the Docker swamps enables you to cluster multiple Docker containers. So I was talking about those things. And then this question was like, let's say I'll give you an example. You have a system, okay? A request comes to your system and it has to go to a third party, okay? The third party is again a REST call. And the response comes back from the third party, and you'll have to send back the the response that came from the third party to the end user or some other system, okay? So let's say you have how will you do bean mappings between your system and the other third party system? Like obviously if you don't use the three elements that are shown here, right, like bean utils, dozer, or map structure, there are actually multiple Java bean mapping frameworks available in the market and the internet. You can actually take a look at it, and these are three most very commonly used. So you can actually, if you don't use this, I'll tell you what happens if you don't use this. Obviously what you'll do is like you'll do a lot of dot set. You'll use the setter to set objects from the response of the third party to your system, and then you'll do a lot of set from, you'll have to create an object from your end, and you will do a lot of set from your end to send a request to the third party. So if you use these frameworks, right, you can just write one line. So it's pretty cool when you use bean utils or mapstruct. It is pretty cool. You just have to write one line, and you'll give the target object and the object from which you will have to move in the values to a target object. So it's pretty cool. So take a look at that. If you don't know about that, it's pretty cool. You can actually suggest it to use it in a project. And then this is kind of like a very common question that's currently been asked in multiple Spring application interviews, like what will happen if you use a prototype bean inside a singleton bean. Obviously, if you use a prototype bean inside a singleton bean, the prototype is going to behave like a singleton. So because singleton is like you're not going to create what is prototype, right? First of all, prototype is like every request it's going to create a new bean, but in case of singleton it's just going to create one and it's going to reuse it. So if you're going to inject a prototype inside it, then it's obviously going to behave like a singleton. There's a very cool example I looked at a few months back in the internet. Take a look at that. If I'm able to find it, right, I'll share the link in my notes. Okay. So the next question was about what is the difference between SLF4J and Log4j. SLF4J is like it acts as a facade between different logging frameworks. That is like, for example, you can use Java util login, you can use Logback, Log4j. These are different logging frameworks. Okay, and SLF4J offers a generic API which makes all these logging frameworks independent of the actual implementation. So it's pretty cool. So when you use this, right, you actually lose the dependency which you have on these multiple log frameworks. So that's one cool thing about using SLF4J. So we talk about that. Then they asked me to speak about the different design patterns that I've used. So this is kind of tricky question, because once you talk about the design pattern, there's going to be definitely a lot of questions about this. So choose your design patterns wisely. For example, I talked about the chain of responsibility pattern and the importance of having the chain of responsibility pattern. I talked about the Vista patterns, and I talked about how we used Vista patterns to eliminate the multiple uses of instance of operator. So then I talked about singleton design pattern. And when you talk about singleton, right, don't stick just to one implementation of singleton pattern, because singleton pattern, there are a lot of different ways of implementing singleton pattern. For example, there is eager initialization, which is the common thing that everyone, when you search in Google about singleton design pattern, right, this is the common thing that comes about. Then there is lazy initialization. Then you can talk about how you can make your singleton reflection proof, because when you use reflection, right, you can actually when you use reflection, you can actually create more than one instance of your singleton. It's pretty easy to create, and how you can stop that. And then you can also talk about how you can make thread safe singleton implementations. And then you can actually talk about usage of serialization, safe from you can talk about how you can make singleton safe from serialization. So these are things that you can talk about. When you talk about these things, right, especially when talking about singleton, it clearly explains the depth of knowledge that you have about design pattern. So these are pretty things that you'll have to know when you go and sit in especially in an API backend developer kind of interviews. Then there was a question about Spring Boot profiles, and the question was like, let's say there are multiple environments, and how will you configure, enable, how will you make all the configuration properties available between different environments without doing much changes to the code. So I told him, like, you can use Spring Boot profiles, and you can configure your configuration depending upon different systems like QA, Dev, and your prod environment, so that you can use one code base and you deploy it, and depending upon the environment, right, those properties will work. So if you have a QA database, you have a prod database, you have a dev database, all these will sit in a different properties respective to QA, dev, and dev prod. Depending upon the environment, these properties will be picked up and used. So there's one cool thing that about Spring Boot profiles, you can talk about that. And then there was a question about functional interface, what is the importance of functional interface, and all those things. So you can talk about a lot of things. Like I would definitely recommend you to go and take a look at the functional interface. Take a look at the most common functional interfaces like predicate, consumer, supplier. So these are things that we mostly use. You can talk about this here. Then you can talk about by consumer, by supplier. Give an example when you will be using by supplier, by consumer, all those things. So then, yeah, these are pretty much straightforward. Okay. So then there was a question about predicate interface, like what function inside the predicate that you have made use of other than is equal. Okay. So then I told him how I used dot negate. There's a negate function inside the predicate. Then I told him how I used negate in different circumstances in my project. So then there was a question about what is the difference between a dot map and dot flat map. So you can say different examples, like for example, map is used to convert one stream into another stream. Let me give you an example. Let's say there's a student object. Inside the student object, let's say there's a list of subjects. Okay, there's a variable called subjects, which is a list of subject. Okay, so you'll have to construct your response to some other systems, and you'll have to change this list of subjects to a list of string. Okay, so obviously you can use dot map to convert list of subject to list of string. So that's pretty straightforward and pretty most commonly used use case of dot map when you want to convert a stream to one particular type to a different type. And then flat map is like, let's say you have three different lists. Let's say you have list of list of integer. Let's say you have three different list of integers and you want to combine all these things into one list of one list, and you want to flatten out the result. That's when you go for flat map. So it's pretty straightforward. There are multiple examples available on the internet. Take a look at that, and these are things that really it's pretty good to know these things. Then there were questions about the testing, JUnit testing, and testing frameworks. We talked about test-driven development, and he was asking me how will you do test-driven development. So I told him like we'll be writing test cases before writing the actual code. So one of the key things to remember here when you talk about test-driven development is like how you actually do it. Like for example, let's say you'll use at the rate of inject to inject some kind of a object into your test case, right? For example, let's say I'm going to write a test case for student controller. So I'm going to do a private student controller let's say injectable test class, and I'll have to annotate with that inject. Then what I'll do is like obviously that's going to be error in the Eclipse. Then so what I'll do is like I'll do a refactor to create the actual class, actual Java class in the package. So the refactor is one of the key words that you have to use when you explain about test-driven development. That is, you write code, it's going to be error. Then you refactor and write the actual code in the Java object. So that's how you write test-driven development. Once you are familiarized with test-driven development, right, it will be really difficult to write actual code and then write the test cases. So these are things that actually shows that you are really worked on a test-driven development. So this was my first round, and I'll see you soon with my round 2 set of questions. Thanks for watching, guys. Please subscribe for more such videos.